This activity is about verifying the principle of Ohm's law. We had to use a circuit construction kit FET simulator for this activity. We placed the battery in the middle of two wires. After that, we connected another wire pointing downwards, then we connected the switch. We put another wire after the switch. After that, we put a resistor. We connected another wire on the resistor and then connected the ammeter. After we have finished the setup, we set the volt of the battery to 25 volts. We then place a voltmeter on the resistor. On the first trial, the resistance was 13 ohms with a current of 1.92 amperes. The second trial, we set the resistance to 17 volts. The current was 1.47 amperes. Third trial, the resistance was set at 19 volts, which had a current of 1.32 amperes. On the fourth trial, the resistance was set at 23 volts. This had a current of 1.09 amperes. And lastly, on the fifth trial, we set the resistance to 89 volts, to which it gave us a current of 0.28 amperes.
The objective of this laboratory is to search about the principle of Ohm's law, where the law states that the current through a conductor between 2 points is directly proportional to the voltage across the 2 points. We use the triangle formula in order to get the right results. In this lab, we observed that the voltage does not increase or decrease. The resistance increases in number as the current decreases its value. We use FET simulator in order to get the theoretical voltage and theoretical current.
On our observation, I noticed that when the resistance increases, the current decreases. After many trials and errors, we still managed to finalize our laboratory experiment.
We've gathered and analyzed the data that we have accumulated during the experiment. The resistance is inversely proportional to the current. Whenever we increase the amount of resistance applied, the current decreases.
In conclusion, we find out the relationship between voltage, current, and resistance in an electrical circuit. The results within the table appears that the resistance and current are conversely relative to each other. It appears that the higher the resistance, the lower the electric current flow, and the lower the resistance, the higher the electric current. It too appears here the Ohm's law guideline, which states that the voltage or potential contrast between two focuses is specifically relative to the current or power or electricity passing through the resistance, and specifically corresponding to the resistance of the circuit.